Hello everyone. Today let's learn about what is BCD.
What is BCD? BCD is known as binary coded decimal, which is a way to represent decimal number in 0 to 9 in binary digits, which is known as bits. So instead of converting a whole number into a binary number, which is like this is used for fast computing. So BCD store each decimal digit separately into a group of 4 bits. Let's give an example. So let's say a number 69. In binary number, it will represent as 1000-101. But in BCD, it will separate two numbers, which is 6 and 9, and convert it into the 4 bits, which is 0110 and 1001. And we combine it together, it will become 69 equals to 0110 and 1001. Okay, so why do we need to use 8 bits exactly? Because computer use register, which is a memory space of a standard size of 8 bits or 16 bits and so on. So 8 bits equal to 1 byte. In computer language, 8 bits register have two logics, which is 1 is true, 0 is false. So why? Because computer rely on the tiny electrical switches, which is a transistor. You can consider as a light switch, which is on is 1 and 0 is off. Now let's talk about how to convert or calculate the decimal into BCD. So there are various ways to count BCD code, and one of the most popular code is 8421. 8421. What is 8421? So given this table here, 8421 method, you can see that if I take 3, we can get 0011, and for 9 is also the same, so 1001. 1 is 8, 8 plus 0 plus 0 plus 1, so we get a 9. So firstly, you need to create a table for the BCD. So for my own method, I'm using a formula or whatever. It's called as 1 plus 1 equals to 10. So 0 is basically 0, 1, 0, 0, 0, and 1. We add a 1 into the 0. So for 2, how do we get a 0, 0, 1, 0? So if we apply the formula of 1 plus 1 equals to 10 here, so 1 plus 1 equals to 10. So 1 plus 1 equals to 10, we can input our 1 into here, and here we become 0. So continue by 3, we will add another 1 into here. So until 4, here already occupied by 1, here also occupied by 1. So if we add another 1 here, it's full. So 1 plus 1 equals 0, equals 10. So 10 will be here. We can get, we put another 1 up here. 1 plus 1 is 10. So put another 1 here. Then we will get 0, 1, 0, 0 for our number 4. So we have covered how to calculate the BCD. So next, let's continue to convert any value into BCD. So to convert any value into BCD, first you need to get a number. So this is your number with decimal. Then using any bases. Then we need to convert into decimal first. Only that we can get into our BCD. So for hexadecimal example, we are using 34D base 16. So D in decimal is 13. And to calculate it, we need to convert into decimal first. So convert 3 times 16 power 2 plus 4 times 16 power 1 and 13 times 16 power 0. So we will get 768 plus 64 plus 13, and we will get an 845 of base 10, which is in decimal. So once we get our decimal, let's convert it into BCD. So in order to convert the decimal into BCD, we need to separate all 3 numbers. We get 8 equals to, using the table, which is 1000, 4 is 10100, and 5 is 0101. So we combine, instead of adding up, we combine these three. So we get 1000, 0100, 0101, and this will become our BCD of the value 34D base 16. And it will be the same for the octodecimal into BCD and the binary for BCD. So for octodecimal, example of 196 base 8, we convert it into decimal. So here is the conversion. So we get 142 base 10 as our decimal. After that, same formula, we separate three of them and we get 1, 4, 2, and using the table you can get exactly the BCD value. So we 0001, 0100, 0010. So 196 base 8, you can get the BCD number. And for the binary, same method. So convert it into decimal, you will get 41 base 10. And 41 base 10 using the BCD table just now, you can get 0100 and 0001. So our binary value for 0010, 1001 base 2 is equal to BCD of 0100, 0001. That is how you can convert any value into BCD value by using the BCD table and the formula given. Next, let's discuss about why are we using BCD in some digital devices instead of binary. So binary is more preferred in the computer system, so it is more on performance, efficiency and flexibility. And the second part is more storage efficiency. It stores data into fewer bits. So in BCD, it stores data separately by separating the digit into 4 bits per digit, so it is using more spaces. And the third part is it supports all kinds of data, so it can support numbers, audio, images and letters and so on. And the last one is more ideal for computing. So binary is more on high-speed calculation, data processing and programming. And for BCD, we can use one of the electrical device in our real life, which is digital clock as an example. Why digital clock is using BCD? So the first point, because it is more human-friendly display. So BCD stores each decimal separately, like we discussed before, and it helps to match each group of 4 bits into a display segment, which is shown in the diagram here. Second point, it avoids rounding errors. So binary will cause decimal fractions, which is like 0.1 or 0 point something, and it will lead to a rounding error. But for BCD, it will avoid by storing numbers in decimal format directly. Since BCD will store the value separately, like 2 is 0010 and 1 is 0001, so it won't cause any rounding errors. And the last point is it is digit by digit processing. So what does it mean? So it makes time increment easier for digital clock. Since it is like 09 to 10, whether it is minutes, hours or second, it can just increment the value directly. So it has no rounding to and binary to decimal conversion errors. So BCD will make it easier instead of using binary. And that's all. So we have covered what is BCD and how to calculate the BCD and create a table for it, how to convert any value into BCD like hexadecimal, octa and binary, and the difference between binary and BCD, and one of the digital device which is used in BCD is digital clock. And that's all. Thanks for watching. Bye bye.